Okay, welcome back everybody. We are going to do procedural textures today. We're going to take this kind of ordinary looking rock and we're going to make it look a little bit better. So at the moment, your rock probably has too many vertices or too many faces on it, simply because, well, at least too many faces for regular scene use. If you're finished sculpting with it, we're going to do a little bit of destructive modeling on your rock, depending on how many faces you end up with. So my rock had about 900,000 faces on it. It was rather a lot. So what I'm going to do is come down here to decimate, and I'm going to use decimate. Right now I've already decimated the rock. If we switch to wireframe, I've decimated the rock to the point where instead of 900,000, it's 90,000. So this is a far more manageable value for using with this application. 100,000, 90,000, something like that. You want to leave a little bit of detailed density, simply because displacement maps work best with more density. So after you set this to the appropriate value by changing this value here, select this little drop down, apply, or Control A on the modifier in the stack. This should apply the modifier. It'll take a little bit of time for it to work. Now your rock should look a little bit more, it should actually look very similar to what it did before. So we'll start by checking out the rock in shaded view. This isn't shaded view, rather, this is viewport, well, viewport shading. It's material preview. So it shows you a material preview of the rock. It doesn't show you anything like any of the cycle settings. It just shows you a texture map. We're going to go over to the rendered view. I've already set up a few things here. We'll just go through those we'll just go through those quickly. The first is I set up a sunlight. So I'll set up another one. Add, go up here to the top here as well. Light, I like to use a space bar. Add light, sunlight. I'm going to just press G, drag it up a little bit, give it a little bit of strength and angle. Go down here to the menu, strength, give it like, I don't know, 10's a lot, so 5. So it gives us a decent light to work with. The sun's usually quite strong compared to almost any other source of light you're going to see. So the next thing I did was I added a HDR texture. So we're going to we're going to remove this just for the sake of replace it with RGB black. So I mean, it's a nice environment to look at as well. So probably I'm going to leave it in with gray because it's easier to see bump maps in this environment. So we're going to leave it there. Select your rock, and you'll notice that we have the principal bsdf. You can set this to, rocks are usually quite non-reflective. So we're going to look back at our reference here. It's almost completely non-reflective. It's almost completely rough. There's no visible reflection. I mean, even the stick here has probably a slightly more reflection than the rock does. Most of these rocks are granite, igneous rocks, so they're not really super dense, super shiny, super hard kind of thing like obsidian. So we're going to change the roughness up quite a bit. But the rock still has, go back, we'll take the texture off because it's easier to see what you're doing with your bump maps if you don't have a texture. So right now, the rock looks all right. It's actually quite convincing. It would pass for a decent rock, but it's got a fairly high poly count still, 90,000. So we can do better than that. I'm going to change, for the sake of being able to see what's going on, or at least be able to see how well bump map fakes geometry. We're going to decimate this even more. If yours is sitting around 100,000, then you might want to do this. If it's sitting closer to like 10,000, then you can just skip this step. But I'm going to decimate that to 0.1 and bring it down to even lower, so 9,000. It's close to 10,000. It's almost 1/10 of what it was. So now we can see the wireframe is very simple. But this is more than enough to fake a rock. with the right settings. You can see it's become much more simple. And there's not that nice detail. So we're going to add a bump map. Shift A, search, bump. Right there. And we're also going to add a noise map. Noise, not white noise, but noise. Gonna go and press Control T. I don't think we need Control T because we already have those. So I'm going to change, well, we're gonna want one that's probably separate from the image. So I'm just pressing Shift D, duplicating the mapping or the vector mapping. So I have a separate vector map for the noise textures because I'm going to want them to be individually controllable. Going to plug in generated. I'm going to hold down Shift and right click. This makes a nice little node junction. This is available when you use Node Wrangler. So I covered it in a previous video, but it's very simple. Preferences, add-ons, type in Node Wrangler, right there. Click that, go back down here, save preferences, close this, and then you'll have access to these functions. Blender has, like I said before, Blender has a great deal of plugins available that ship with it. They are Blender plugins. They're not like aftermarket, they're not dangerous, they're not virus infected or whatever. They come with Blender, they're developed specifically for Blender. It's just that Blender doesn't have them all enabled initially. It makes the program a lot lighter. So you can tailor it to your uses or preferences because there's usually about 6 or 7 different ways of doing something in Blender. And they all produce the same result. So Shift A, ramp, color ramp. Grab my mic here, it's kind of in the way. Shift A, color ramp, come on, color ramp, there we are. So we're gonna add this to our noise texture, organize it, just because it looks neater. Hold down Control while you're moving one of these nodes, allows it to snap to the grid in the background. So we're gonna plug factor into factor. We're gonna plug color into strength, and then normal into normal. So it doesn't look like anything's happened. So I'm going to unplug the albedo map, because with the albedo map there, it's hard to tell what's going on with the bump map. So again, it doesn't look like anything's happened. I'm going to change this value here back to 1. Still doesn't look like anything's happened. And it looks like everything's set up correctly. So we're going to change the noise scale detail to 10. And it should be doing something. Why is it not doing something? Ah, it should be plugged into height, not strength. Well then, okay, so, and this is our bump map. So what noise does essentially is we're going to change this back to 1. This is noise scale will change the apparent scale of the noise effect. And detail will change the granularity of the effect. So what we're trying to achieve, according to our image here, is we're trying to achieve a certain kind of uniform texture, but not completely uniform. So it does have a lot of uniformity to it, but you want a lot of variability in that uniformity just to give it a bit more interest. So it's not just like this similar thing. It's like most things in nature have a great deal of variability in their texture maps or texture appearance. So to do that, instead of raising the value all the way up like this, we're going to lower it way down, and we're going to increase the texture detail, and then we're going to increase the roughness, not too much. These sliders can be played around with. They're there to be used. So this is already extremely similar to what I can tell from this rock. But we can do a little better than this. we're going to layer in procedural effects. But first I'm going to cover the difference between a procedural effect and an image texture. An image texture has a fixed resolution. So a 6K image texture is going to always be 6K. It's not going to change its resolution based on how close you are to the model. We can see this by unplugging the bump map and looking at our model from different distances. From this distance, this 4K texture looks quite good. It's very convincing, it's very detailed. If we zoom in, we can see that it's going to start looking and see, you're going to be able to start seeing the fuzziness of the image. It's a JPG, so it's going to have that interpolation that allows it to pack data into a small size, but it's going to also fall apart a little bit. And it doesn't even matter if it's not a JPEG. It's just JPEGs have this kind of fuzzy look to them. But you can see that it doesn't scale infinitely. It's a fixed image. Whereas with procedural textures, we plug in the normal here and we'll unplug the albedo. If we zoom in, it's infinitely granular. The closer you go, it's exactly like one of those fractal patterns. It keeps generating information. That's one of the primary benefits of using a procedural texture. Another one is that you can map images, you can map things and have certain variables of the scene affect those procedural textures in dramatic ways that you wouldn't be able to do with an image texture. So that being said, I have a list of textures. I'm going to add another. I'm going to add a Musgrave. Shift A, search Musgrave. Musgrave texture. All right. I'm also going to add a color ramp for that. Shift D, duplicate the color ramp. Just like that. And I'm going to add a mix RGB. Mix, I can't see my keyboard. Right here. Not going to plug it in yet. Voronoi. Voronoi is quite cool because it'll give us this really neat little ridged effect in the rock. The Musgrave gives a very interesting noise effect that's more variable than the distributed appearance than the traditional noise, but you can get quite a bit out of the traditional noise. You just layer in noise, and it's a very flexible procedural texture. Add another noise. That's the wrong one. Noise. I could just shift D, I suppose. Noise texture. And we're going to add yet another noise texture right here. And we're going to add another mix RGB down here. Duplicate the color ramp. Your workflow won't look quite like this because I've already gone through this texture a few times, so I'm just going to give you this outlook to show what it looks like. But usually when you're building a procedural texture, it's a bit more haphazard. You clean things up, you streamline things here and there, reconnect nodes, that kind of thing. Another mix shader or mix RGB right here. So we're going to start and we're going to layer in the effects so you can see the difference. We're going to shift, we're going to add another node here just because. Add this one. And that's the Musgrave. Musgrave gets plugged into the color ramp. And these will both get plugged into this. So if you want to see what something looks like, to preview a node, Shift, Control, and click. And this will preview just the node and it'll isolate you from every other node. So right now we can see that this mix shader is mixing between the Musgrave and the noise texture. This doesn't look like much, but it doesn't take much. The sensitivity is pretty narrow. It's only a 1 difference in floating point, so 0 to 1, and everything in between that number and 1 and 0 for a floating point number. The bump map will pick up those values. It doesn't look like much on the screen, but the bump map does pick up those values. So if we want to, we'll turn it back here. The noise is, this would be just the noise. So we're going to sharpen the noise with our color ramp, just for the sake of visualizing it. and we're going to see what that does. It's got this really cool distributed random effect. We're going to see what that does for our primary, just hiding back here, our primary bsdf. So what we've done is we've isolated the range. You can replace these color ramps with a map range node. They're not very intuitive, but essentially they do the same thing as a color ramp. What you're doing with a color ramp is you're taking an input from 0 to 1 and you're altering the output. So if I was to alter this, I can chop the range that the output is producing color at and change it, pinch it or expand it, mostly just pinching it. Change its interpolation, so linear, B-spline, it's softer. And B-spline is preferable in many situations because you don't want it to be too harsh. This is quite nice because if you had it cut off with linear, you can see the cutoff lines. But if you change that to B-spline, you can't see the cutoff lines, but there is an influence that they're still applying to the actual color grade. You can see that right there. It's making it softer. And that's just with noise. That's actually quite good. So you can do that. You can play around with map range as well. You see the value, you plug your value in, and then from and to, essentially it's 0 to 1, 0 to 1. Same idea. For now, we're going to just use color ramp. So now we want to see what it looks like mixed. This is what it looks like just with the noise. And this is what it looks like mixed. So we have factors to set to 0, which means it's mixing none of the bottom one and all of the top one. We're going to mix in some of the bottom one, all of the bottom one in fact, and we're going to work on this bottom one. So this one I have it set at 6.7 for scale, 4.7 for detail, dimension I think is 0, yeah. And luminosity is 2.8. So this gives us a very interesting pattern effect. If we mix this with our other pattern, it's quite a bit sharper. So what we can do is we can actually, two ways of changing that sharpness. We can change the value here so it's not as bright. We can, excuse me, we can change this so there's not as much, because there's quite a sharp fall off here. It's very, very sharp. We can also add a math node. Inline, drop it in line here, and it'll alter the data that's received by it. So we change that to multiply. We're now dividing or multiplying the data based on what number you set here. So make it brighter, make it dimmer. That's one way of altering one of these node trees or lines for the maximum effect. I'm gonna plug it in. We can also change this to something else, like let's say screen or lighten. Let's say we want screen. Oh, that actually looks pretty good. So what does this look like? We're going to plug it into bump map, find out. You know, it's getting somewhere. Looks interesting. There's like these little rock shelves or maybe some lichen or some debris on the rock itself. Maybe slightly less of that effect. That's pretty cool. What about ease? What about B-spline? That's very, very bright, very strong. It's obviously a very strong effect. It's washing out the noise. So we might want to add, there's a couple of ways of changing this. Often the simplest way, just for ease of workflow, is to add a math node. Essentially, it's the same as changing one of these pins, but for the sake of it, you have a little bit more direct control. If I was just to change this to 0.1, so I have a lot of linear, like a lot of granular control here. And what I'm going to do is I'm going to change that Musgrave, the scale, it's going to go down. And now we've got some distributed detail on our rock. But we can do even better than that, at least in my opinion. The second part we're going to do is we're going to plug in our Voronoi. We're going to plug this in here. I'm going to just move this out here so it's easier to see what's going on. We're going to plug this into one of the color maps and the other one into the other one. Oops. No, go in there. There we are. So, yeah, something like that. Not like that. Okay. Sometimes it gets confused about, there we are, which is the input. There we go. Okay. Now, what I'm doing here is I'm taking a vector and I'm running it through a noise texture. And then I'm running the noise texture into a mix RGB node. The mix RGB node is set to mix, and the texture will be mixed between the original vector and the noise altered vector. Since a vector can be extrapolated by Blender into red, green, and blue, that means that anything that works on red, green, and blue, red, green, and blue can actually affect the vectors correctly. A vector is a set of three numbers, three floating point numbers, and that's essentially what a red, green, and blue values are. So we're going to plug this into the vector for the Voronoi. Then we're going to plug in distance, and we're going to plug in distance, and we're going to preview what that looks like for now. So this gives us a very interesting look. I'm actually curious what this is going to look like plugged right into the bump map. So quite sharp. All right. So if we play with the factor of this mix shader, we can see mixing in the one channel, the one vector that's altered by the noise texture all the way to nothing, just the original vector. So this is what the noise texture is doing to the vector and then output through the Voronoi texture. I'm going to set the Voronoi to Euclidean 11.5. And randomness should be set to 0.48. And we're going to change the noise to 2.4. 15, highest detail. Like right away, that looks really nice. And roughness is going to be set to almost 5, so 1.52. Yeah. And this is with all the noise affecting the Voronoi texture. And it's an interesting look, but it doesn't really look like a rock. It does sort of look like a rock. Could change and mess around with the scale. I'll leave it set to 2.4. So now let's change this so that the Voronoi texture is taking over more control. And it's starting to look a little more like a rock. So what we're going to do is we're going to flip these color profiles. So now it looks like we're producing cracks or bulges in the rock instead of the other way around. What that looks like when you flip the color profile, you have highs and lows represented differently. So we're going to change this to something else like Manhattan. I want to go back to the original. There we are. Manhattan looks pretty good. We're going to check a few of the other ones. They definitely bear a certain amount of experimentation. I'm going to leave it there. And we're going to add in another noise texture. This one will be linked to the original. Like so. Factor. We're going to stick this one in here, and we're going to mix this one through here. So remember, our original texture looks like this. So now if we add or mix these two, which I'll do right now, what we currently have is we currently have this, and we currently have this, and they're mixed. So we can change these, play around with them. So we get a little bit of variation there. It's pretty cool, some ridges. But let's say I don't want the ridges everywhere. So I'm going to preview just this one in bump-map. It's kind of hard to see sometimes when you're previewing to just see like this. It's like, well, I don't know what that's doing. So it's just easier to plug it into the bump-map node and see the difference, because the bump-map will take some very, very fine differences in value in the image, and it'll produce very dramatic results. So we're going to change the noise texture here to 10 as a starting point, and details again 15. And roughness is 0.5. So it doesn't really look like it's done anything. But what we want, or in this case, what I want to remove some of this Voronoi texture. Essentially, I want to remove some of that. Now we're going to change this to mix. Here we are. I want to remove some of this Voronoi texture, and I want to replace it with nothing, so that we don't get as much Voronoi texture scattered everywhere. So what I do is I add a multiply RGB shade, an RGB mix node, and set it to multiply. And I'm going to multiply by another node or another group. And what this should do is it will remove parts of this group because it's multiplying by this one. And anything that's black will be reduced to 0, because anything multiplied by 0 is 0. And the black value is represented by 0. So as you can see, it's doing something, but it's not quite clear what it's doing yet. So we're going to change the black values here. And you can see that the image map on the top here, this one here, is actually starting to fade because of the multiplied value. So this is good, because it means that once we plug it into our bump map, we can actually remove portions of the other map, essentially masking them out. So instead of detail that's so high, I'm going to change this to 5. And I'm going to change this to ease, or maybe B-spline. Yeah, B-spline. No, not sure. Maybe ease. Maybe change the intensity a bit, like that. And now if we plug this one into here, we can preview this. It doesn't help sometimes because it's like you don't know what this is doing in a bump map. But we'll plug this one into height. We'll preview this, and it's giving us something. So let's see what it's giving us in combination. It's not quite sharp enough to match the other map, quite bright enough rather. So one thing we could do at this stage, because this is the map before, and this is the other one. It's very soft. So we could change the output. Search. No, we're looking for math. Drop that in between, multiply. Now we'll change this value up, and it should give us a more dramatic effect. And it does. There's still a few areas in the rock that don't seem to have any texture on them or any bump mapping. We could probably change that by instead of using mix, we could probably use lighten or maybe screen. As it is, though, I'm rather happy with that result. What we're going to do now is we're going to separate the vector coordinates for these things. Right now they're being driven off of the same one here. We're going to change this, go down here. The input is still going to be the vector output of this. So we're just going to have three different sizes as you would have it. We'll search value. Plug that in there. Switch this to, well, 1 for now. And we're going to plug this in here somewhere. So we're going to change this one like this. And plug these together like so. This is probably unnecessary. Here. So now we have a separated system for our second, our Voronoi set. And it'll scale up the whole set. You can change the ridginess or the lumpiness or whatever of the rock you're making. There's so many different variabilities here. The possibilities are almost endless. Change this way down. And change this up, maybe. Give us some really strong details. And already that looks a great deal more detailed than you would get from a low poly model. This would have to be millions of polygons to get this kind of high resolution detail in a rock or any other object for that matter. And it's all fake geometry. So one more thing I'll cover is the difference between a bump map and a displacement map. There's not much difference. They both appear very similar. They use vector mapping. So I'm going to use add displacement. The way you deal with them in Blender is you plug them in the same way, height, and then you plug displacement. Instead of into the bsdf, you plug it into the material output. And you have to be in the viewport shading or the shaded mode in cycles for this to work. It won't work in Eevee. As you can see, there's nothing here and there's crazy stuff here. So what we need to do to get this to work, because I've already set it up, is you need to go down to textures, select your rock, scroll all the way to the bottom, go to settings right here, go to this surface, and then under displacement and bump, it's usually selecting bump. So look, there's no displacement. Now we're going to add displacement and bump, and that adds displacement. Now it does look like an unusable mess right now, or unusable mess, but we're going to fix that. I'm going to go down to displacement, and we're going to do two possible things. The first we're going to do is change the mid-level to 0. So what happens is with displacement you have a mid-level is the value that it wants to take for the middle of the mapping. It will push down or raise up values based off of the mid-level. So if you set it to 0, the mid-level would be black. And I'm going to set the scale lower, like this. And this will actually change the geometry. You can't really see it because when you press a wireframe, it's not changing anything because it's not in the shaded view. But this is changing the geometry. If you look at the profile or outline, you'll see that it is actually changing the geometry. Whereas if we were to look at just the bump map, if you look at the profile or outline, it doesn't do anything to geometry. So displacement isn't as useful in scenarios where you have a low res mesh because there's not enough detail on the mesh to make a difference. It can work in many situations if you have a very straight line and you're trying to make it look more organic. You add a little ripple or a bit of a detailed ruffle or something to it. This is a very quick and easy way of doing that. So for now, we're just going to leave displacement off. And I think that just about wraps up the first look at the shader editor and the use of nodes. So the last thing we're going to do is add a camera to your scene. Shift Control or Shift Alt 0, I believe it is. No, Shift Control 0. There we are. Shift Control 0 will snap your viewport or snap your camera to your viewport. So it moves the camera to the current viewport camera. We're going to lock the camera using this particular lock view to camera so that we can move the camera. And we're going to plug back in the texture just to see what it looks like. We're going to render it out. Plug the albedo map back in. And to make it look kind of cool or interesting, we can add a environment map. Go into your world settings, go into color, click this little button thingy here, this little dot, environment texture. Go down to your node editor or your shader editor, go to world. Then under here you have to select your HDRI that you want to use. So I'm just going to select a sunny HDRI for once. Gives me a bit more directional light. So now we do have both our sun lamp and our HDRI at the same time, running at the same time. So you're going to get different directional directional lighting. Ooh, losing my voice. It's a very diffuse light from the HDRI. I mean, we could increase that. Go into environment. There's strength setting for HDRIs. So you can blow it way out or whatever. But for now, we're going to leave the sun on just so that we can see a better look at what the rock looks like. And we're going to go up to our settings here, make sure it's on cycles, GPU compute if you have it. Check out my look at whether optics is worth it video to learn more about how to use optics for NVIDIA GPUs to render your scene faster. Go down to Filmic, right at the bottom, color management. This is still under the render properties tab. Instead of selecting, I think it's on none, which is okay. That's not a bad contrast. It's more realistic. You get more pop if you select more punch, high contrast. Apparently, no contrast and medium contrast are the same. So, high contrast. For now, I'm going to select none. And we're also going to change the exposure for the scene slightly, I think. It really depends. Maybe it's not necessary. Go back to the sun lamp. See if that could use some more light. Can it? I don't know. It's all up to the individual. Actually, that makes it look like it's inside. Now, see what it looks like. I'm going to change that back to high contrast. I'm going to render it. And that is how you texture map bump maps for rock. That's how you use procedural textures. It should have covered everything you need to know to begin procedural textures. The next one, we're going to look at some more diversity you can add to procedural textures. It's a little bit more advanced, not terribly more advanced, but it is more interesting in many ways. So stay tuned for that, and we will see you then.